Hello everyone. So here we shall solve some previous year questions on the chapter current. This video we shall start from question number 6 on previous two parts. The question number 4. If you have any questions in any steps, questions, or doubts you have, then please write us in the comment section. And in any other chapter of physics, if you feel more difficulty, then also mention the name of that chapter in the comment section. And also the homework questions on every chapter will be uploaded the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told to find the effective resistance in between the points A and B. So here we can see that now this we can say this point A. Let's say so this is point B. Let's say if I take this is the point C. Suppose we take this point as C. This point will be B. This point also will be A. This point is suppose D. So you can say that in between A and C there is one resistor. It is of 10 ohm. In between C and D there are two resistances in series, 10 ohm and 10 ohm. And in between A and D there is another resistance, 10 ohm. In between D and B there is another resistance, 10 ohm. And in between B and C also, between B and C there is another 10 ohm. So we can draw this like this also. This is point A, point C, this is point D. Between C and D the equivalent resistance is 20 ohm. Between A and C there is 10 ohm. A and D there is 10 ohm. In C and B there is 10 ohm. In D and B also there is 10 ohm. So it means that it is a Wheatstone bridge. So therefore this 20 ohm I can just cancel it. So therefore the equivalent resistance in between A and B, that will be equal to these 10 ohm are in series, and this 10 ohm are in series. And between A and B there is, this is 20 ohm and this is also 20 ohm. So 20 and 20 is 10 ohm. Option A is the correct answer. 1 second. So question number 46, option A. Question number 47 is told two heating coils of resistances 10 ohm and 20 ohm are connected in parallel and connected to a battery of EMF 12 volt. Two heating coils are there, which is of resistances 10 ohm and 20 ohm, and they are connected in parallel and they are connected to a battery of EMF 12 volts and having internal resistance 1 ohm. The power consumed by them are in the ratio. So if so currents also will be in the ratio 2:1. So here the resistances are in the ratio 1:2, so current also will be in that ratio only. So from here, if I current flows, then from here 2I/3 current will flow, and from here I/3 current will flow. So therefore the power consumed by them, so the power consumed by the 10 ohm, let's suppose it is P1, and power consumed by 20 ohm is suppose P2. So P1 by P2 will be, this is 2I/3 whole square I square R divided by P2, that is I/3 square into R. This will be 4I square by 9, 10 divided by I square by 9 into 20. I square by 9, I square by 9 will cancel. So this is 40 by 20, that is 2/1. 2:1. Option C is the correct answer. In question number 48, it is told the quantity of a charge that will be transferred by a current flow of 20 ampere over 1 hour 30 minutes period is. The quantity of a charge that will be transferred by a current flow of 20 ampere for a time period of 1 hour 30 minutes period is. So Q is equal to I into T. How much charge will flow? So 20 ampere into 1 hour 30 minutes means it is 60 minutes. So this is 90 minutes. So it is 90 into 30 seconds. Sorry, 90 into 60 seconds. Since 1 minute is 60 seconds. So this is 20 into 90 into 60. This much coulomb. So this will be 2 nines 8, 2 12, 12 nines are 108. 108 into 10 power 3 coulomb, or we can say it is 10.8 into 10 power 4 coulomb. So option B is the correct answer. Question number 49 says, in meter bridge experiment with a standard resistance in the right gap, in meter bridge experiment with a standard resistance in the right gap and a resistance dipped in water, the standard resistance. So in a meter bridge experiment, here we have one resistance and here we have another resistance. Here we have the resistance where here we have the jockey is here. Current will flow. Now standard resistance here in the right gap and resistance dipped in water in a beaker in the left gap. So okay, so standard resistance in the right gap and resistance coiled dipped in the left gap. The balancing length obtained, this part is kept in water and the balancing length is L. This part is 100 centimeter. If the temperature of water is increased, the new balancing length is. So when temperature is increased, then the resistance of this wire will also increase. Resistance of this will increase, means that the balancing length also will increase to obtain the Wheatstone bridge condition. To obtain the Wheatstone bridge condition, when this R will increase, when temperature of the water is increased, then this R will also increase, and then this balancing length also has to increase in order to obtain the Wheatstone bridge condition. So as to obtain the Wheatstone bridge condition. That's why we should say that this R by L should be equal to S by 100 minus L. So when R will increase, this L also has to increase so as to keep this ratio as constant. Now standard resistance. So it will be greater than L. The new balancing length will be greater than L. Option A is the correct answer. In question number 50 is told that of the following graphs, the one that correctly represents IV characteristics of a ohmic device is. Ohmic conductor is that which follows the Ohm's law. Means that IV curve should be a straight line. Since it is the ohmic, so it should follow the Ohm's law. So means that option A is the correct answer. The value of I, the figure shown below is, so here you have to apply KCL actually. This is 20 ampere, this is 4 ampere, this is 5 ampere, this is 3 ampere, this is, no, since this is 5 ampere, this is 20 ampere, so 5 ampere goes here, so here actually 15 ampere should go. This is 3 ampere, so this should be 2 ampere. This is 4 ampere and this is 15 ampere, so when we add them here, 19 ampere will come. 19 ampere plus 2 ampere, that is 21 ampere. I should be equal to 21 ampere. Option B is the correct answer. Question number 52, it is told the power dissipated in 3 ohm resistance in the following circuit is. Power dissipated in the 3 ohm resistance. So this we can draw like this also. This is the uh, battery. The battery is having voltage 0.5 volt and internal resistance is 1 ohm. Internal resistance. Across these 2 points we have like 4 ohm. This is 3 ohm. This is 6 ohm. This is 2 ohm. Now 3 ohm and 6 ohm are connected in parallel. That's why their equivalent is 2 ohm. 2 and 2 are connected in series. Their equivalent is 4 ohm. 4 ohm and 4 ohm are connected in parallel. Therefore, their equivalent is 2 ohm. Therefore, R equivalent in the whole circuit is 2 plus 1, that is 3 ohm. So therefore, the current that will flow from the battery, the current that will flow, that will be 4.5 volt by 3, that is 1.5 ampere. The 1.5 ampere through this will be also having equivalent resistance 4 and 4, so same current should. So here 0.5 ampere, here also, sorry, 1.5, so 1.5 half, Here also 3 by 4 ampere, here also 3 by 4 flow. So through the 3 ohm resistance, so the current that will flow through the 3 ohm resistance, I1 suppose, I1 will be equal to 6 ohm divided by 6 plus 3 to this current, which is 3 by. So this will be equal to 6 by 9, 3 by 4 here. 3 plus 6, 3, 3 are 9, 4.5 ampere. Now therefore the power dissipated in the 3 ohm resistance, power dissipated the 3 ohm resistance, that will be equal to I1 square into R, 0.5 whole square into this resistance 3 ohm, that is half square, that is 1 by 4, 3 by 4 watt, which is equal to 0.75. D is the correct answer. Question number 53, it is told piece of copper is to be shaped into a conducting wire of maximum resistance, suitable length and diameter are. A piece of copper is there, is to be shaped into a conducting wire. Piece of copper shaped conducting wire of maximum resistance, suitable length and diameter are. So copper shaped into a conducting wire of maximum resistance. R should be maximum. Suitable length and diameter are. So the resistance is rho L by A, piece of copper. So the volume is constant actually. Area is pi d square by 4. So you can write L by pi d square by 4 rho by pi L by d square. Therefore, the resistance is proportional to L by d square. It means that the length should be high and the length of the copper wire should be high and the diameter should be low. Then only the resistance will be high. So here the highest length, it means the ratio of L by d square should be the highest actually. So if we take 2L and d by 2, then it will be, so option B is the correct answer. Since by 2L by d by 2 whole square if I do, then it will be 4 into 2, that is 8L by d square is the highest. Question number 53, option B is the correct answer. Question number 54, it is told a cylindrical conductor of diameter 0.1 millimeter carries a current is 90 milliampere. The current densities. Now the current density, which is J, that is given as I by A, which is current per unit area of cross section. That is I by pi d square by 4. I by pi r square. So this will be 4I by pi d square. This is the current density, which is by J. And pi value we have to take approximately as 3. This is into 90 and 10 power minus 3. Pi, that is 3 into d 1 mm, it is 10 power minus 4 meter, it means 1 millimeter is 10 power minus 3 meter and 0. So power minus 4 meter, so 10 power minus 4 square, 3 3 is, so 4 3 is 12, 20 into 10 power the 8 minus 3 is 120 into 10 power 5, and 2 into 10 power 7 ampere per meter square. So option A is the correct answer. Ohm's law is applicable to diode, transistor, electrolyte, conductor. So it is applicable to only conductor. Since why the IV characteristics is a straight line, the I versus V graph should be a straight line only in the case of conductor. So it is following the Ohm's law. Option D is the correct answer. So it is here it is told if the last band of the carbon resistor is absent, then the tolerance is. So if the last band is absent, then the tolerance is 20%. So option B is the correct answer. For gold, silver, and no color. Silver and no color. So for gold, the tolerance is 5%. For silver, the tolerance is 10%. And for no color, the tolerance is 20%. Question number 57, it is told the effective resistance in between P and Q for the following network is from P to, let's say, A, 4 ohm. This is, then A to R, there is A to R, there is 3, and this is also C. So 3 plus 3, that is 6 ohm, and here also one more A to B, that is 6, and then B to Q, that is again 5 ohm is there. So effective resistance in between P and Q. So 6 and 6, its R equivalent is 3. So R equivalent, that is equal to 4 plus 3 plus 5, since they are in series, that is 7 plus 5, that is 12 ohm. Option C is the correct answer. Question number 58, it is told 5 identical resistors, each of resistance R equal to 1500 ohm, are connected to a 300 volt battery as shown in the circuit. The reading of the ideal ammeter is. So now here the R equivalent is 3R, no sorry, R by 3, since three equal resistances are connected in parallel, and here 2 resistors are connected in parallel. Therefore here it is, here this is the ammeter and this equivalent is R by 2, and here we have the battery which is having EMF 300 volt. The reading of the ammeter is how much? Okay, it means that how much current will flow the circuit, that is their R equivalent is R by 3 into R by, so it will be like 1 by R equivalent is like 1 by, so by R plus 3 by R is 5 by R, so R equivalent is R by 5. So how much current will flow? So R equivalent is 1500 by 5, that is 300. So therefore current will be equal to 300 by 300, E by R equivalent, that is 1 ampere. 1 ampere current is flowing. 1 ampere current is flowing. So through this, how much current will flow? Through R by 3, how much current will flow? So that will be R by 2 divided by R by 3 plus R by 2 into 1. So this will be the current reading in the ideal ammeter. Actually, the ammeter is connected here. Okay. So through this I1 current is flowing. So through this also I1 current will flow. So this I2 current is flowing, where I2 plus I1, that is 1 ampere. So I1 will be, since current will be divided in the inverse ratio of the resistances. This is R by 2 by R by 3 R by 2, that is equal to R by 2 by, this is 6 2r plus 3r into 1. So this is equal to r by 2 into 6 by 5r. So 2 3s are 6, 5 r and r cancel. So 3 by 5 ampere. So this 2 by 5 ampere. 3 by 5 ampere. So option B is the correct answer. And in question number 59, it is told two cells of internal resistances R1 and R2 and of same EMF are connected in series across a resistance R. Across a resistance R, across a resistor of resistance R, two cells of internal resistance, R1 and R2 same EMF are connected series. Okay. R1 and R2 same EMF E and E. Okay. If the terminal potential difference across the cell of internal resistance R1 is 0, the terminal potential difference across this is 0, the value of R is, let's say this point is A, this point is B, so it is told that VA minus VB, that is equal to 0. So then R will be how much? Okay. So it means from here we can say that E, if we apply KVL from here to here, we'll say that VA minus IR, VA minus IR, here how much will be the net current in the circuit? That will be equal to E by 2E by R1 plus R2 plus R. Now therefore VA, you can say current is flowing like this. You can say that this is VA minus E plus IR1 is equal to VB. It's VA minus VB, that is equal to E minus IR1, that should be equal to 0. Means E should be equal to I into R1. Means E, that should be equal to 2E R1 by R1 plus R2 plus R. So E and E will cancel out, then we can say that R1 plus R2 plus R, that is equal to 2R1. So therefore R should be equal to R1 minus R2. So option C is the correct answer. And in question number 60, it is told IV graphs for two different electrical appliances P and Q are shown in the diagram. If RP and RQ be the resistances of the devices, then what is the relation in between RP and RQ? So I versus V graph. So this is for the electrical appliance Q, this is for the electrical appliance P. So we know that the slope of IV graph, slope of I versus V graph is 1 by R. It is not R. V, if the graph is V versus I, then it is R. Then the slope is R. But for the I versus V graph, the slope should be 1 by R. So therefore, here the slope is higher. Therefore, I can tell that 1 by R for the Q, that is greater than 1 by R for P. Is that 1 by RQ, that is greater than 1 by RP? Is that RQ is less than RP? Is RP is greater than RQ? Option B is the correct answer. Then in question number 61, it is told though the electron drift velocity is small and electron charge is very small, a conductor can carry an appreciably large current because electron drift velocity is small, and electron's charge is also very small, conductor can carry an appreciably large current, means I equal to NEAVD. So it means that in, in spite of E and VD be very small, but this N is very large. That is why the current is appreciably large. Means that the number density of electrons is very large. It means option B is the correct answer. In question number 62, it is told masses of 3 wires of copper are in the ratio 1:3:5. Masses of 3 copper wires. Masses of 3 copper wires are in the ratio this. Let's say M1 is to M2 is to M3. Their masses are in the ratio 1:3:5, and their lengths are in the ratio L1 is to L2 is to L3, 5:3:1. The ratio of their electrical resistances are. So mass, I can say their density to volume, and volume means area into length, area of cross section into length. So let their lengths are L1, I can write that is suppose 5L, L2 is suppose 3L, and L3 is suppose L. So M1, so I can write that is A1 L1 is to rho 1 L1 L rho 1. So rho will be the same since all the 3 wires are made of the same substance, that is copper only. All the 3 wires are made of the same material, that is copper. So all 3 wires will have the same density. This rho is not the electrical resistivity, that is the density. So I can say it, suppose it is let's say I call it as D instead of rho. It is D1 A1. So DA1 L1 is to DA2 L2 to DA3 L3. That is equal to 1:3:5. It means I can say like D will cancel out. So A1 into L1, that is 5L, is to A2, that is, so A2 into 3L into is to A3 is to L to L, that is equal to 1:3:5. Therefore L I can cancel out. Therefore 5A1 is to 3A2 is to A3, that is equal to 1:3:5. So suppose if I tell A3 is equal to suppose 5L, 5A suppose, then A2, 3A2, that is equal to 3. That means 3A2, that will be equal to 3A, is that A2 will be equal to A. 5A to A1, that is equal to A, means that A1, that is equal to A by 5. So the ratio of the electrical resistances. Therefore R1 I can say it is rho L1 by A1, where rho is the electrical resistivity, is not density. We are calling D as the density of copper, but rho is the resistivity of copper, we are saying. This will be rho into L1, that is 5L, divided by A1, that is A by 5. This will be 25 rho L by A, and R2, that is equal to L2 by A2. Rho into L2 is 3L by A2, that is A. This is 3 12 by A, and R3, that will be 12 3 by A3. Rho into L3 is L, and A3 is 5A. This will be 1 by 5 into 12 by A. Therefore, the ratio of their electrical resistances, R1 is to R2 is to 3, that will be equal to 25 is to 3 is to 1 by 5. Therefore, we can multiply all of them by 5. So this will be 25 is to 15:1. So option C is the correct answer. Then in question number 63, it is told in the given circuit, the current through the 2 ohm resistor is how much? Through the 2 ohm. This is the cell, electric cell, the battery is having EMF 1.2 volt. This is 1 ohm. This is 3 ohm. This is 2. This is 1. Actually, through this part, no current will flow since this part is a conducting wire. So all the current will flow through this part only. The current will part. So it means from here also no current will. All the current will through this part also, but only. So through here also no current will flow. Through here also no current will flow. All the current will pass through this part. So the equivalent resistance R equivalent is ohm plus 1 ohm, that is 3 ohm. So therefore, much current will flow through this is equal to 1 point divided by R equivalent 0.4 ampere. So option A is the correct answer. In question number 64, it is told Kirchhoff's junction rule KVL is a reflection of conservation of charges, conservation of energy. Okay, so conservation of energy, conservation of energy, conservation of charges. Option C is the correct answer. Conservation of charges. Here, net current, conservation of charges, Kirchhoff junction rule means it is the KCL. KVL is the loop rule, Kirchhoff's loop rule. KVL is called loop rule, Kirchhoff's loop rule. But KCL, which is the Kirchhoff's current law, it is called as the Kirchhoff's junction rule. So Kirchhoff's loop rule is based on conservation of energy, but Kirchhoff's junction rule is based on the conservation of charges. C, the correct answer. If it was asked that Kirchhoff's loop rule is a reflection of, then it would have been D. Question number 65, it is told the variation of terminal potential difference V with current, the variation of terminal potential difference V, current flowing cell is as shown. The EMF and the internal resistance of the cell are terminal potential difference of cell, so it is having the internal resistance R and EMF is E. Current is flowing through the cell, so the terminal potential difference will be E minus IR. Minus IR. So now it means that when this is V versus I graph, so when I is equal to 0, V will be equal to E. So here the graph is like this. When current is 0, then it is 3 volt, and when current is 6 ampere, then the net terminal voltage is 0. It is terminal voltage versus the current. V is the terminal voltage versus the current flow. That means that V is equal to E when current is 0, so E is equal to 3 volts, and it is the EMF of the cell, and E is equal to 0 when I is equal to E by R. E by R, that is 6 ampere. So now therefore E is 3 volt, 3 by R, that is equal to 6. So R is equal to half, 0.5 ohm. 3 volt and 0.5 ohm. So option D is the correct answer. Then it is told in a potentiometer experiment, the balancing point with a cell is at length 240 centimeter. There is a cell and then the balancing point is here. Balancing point is at 240 centimeter. The cell, on shunting the cell with a resistance 2 ohm, the balancing length becomes 1. Here it is having internal resistance R. When the cell is shunted with a resistance of R, resistance of 2 ohm, then the balancing length becomes 120 centimeter. The internal resistance of the cell is. So here then the equivalent EMF will be E by R plus 0 by R plus by 2. Equivalent is E by R by 2 plus R by 2R. E by plus R, 2R by R is 2. 2E by 2 plus R equivalent. The internal resistance of the cell. Internal resistance of the cell is asked. Shunting the cell with a resistance of 2, the balance length becomes 120 centimeter. The internal resistance of the cell. Internal resistance of the cell. When there is no when it when the cell is not shunted, then we can say that E will be equal to phi into L1, where phi is the potential drop, voltage drop per unit length in the potentiometer, where voltage per unit length in the potentiometer, drop per unit length potentiometer into L1. Equivalent is phi into L2. Therefore, E is equal to phi into 240 centimeter, and E equivalent, which is 2E by 2 plus R, that is equal to phi into 120 centimeter. So if we take their ratio, then we will get that E by 2E by 2E by 2 plus R, that is equal to 40 by 120. 2. That means that this E and E will cancel. So this is 2 plus R by 2, that is equal to 2. Plus R, that is equal to 4. That means R is equal to 2 ohm. 2 ohm is the internal resistance. Option D is the correct answer. Then question number 7. Question number 67, it is told a metal rod of length 10 centimeter and a rectangular cross section. Okay. So the remaining questions we shall solve in the next part of this video on current electricity. So hope that you all have understood till the question number 66, and if you have any questions or any doubts in any of these solutions, then please write down in the comments section. uh, uh, and please install our Sapience education application, where we shall upload some very important homework questions every chapter. Here we shall end this part 3 on current electricity. Thank you everyone.